right. So the first question was, well, they're telling you that there's a flight departing Chicago and landing in Atlanta, and we want the ordered pairs for those airports. So what is the ordered pair for Chicago? Anybody? Shout it out. Thank you. All right, what about Atlanta? Good. So because if we're looking at this grid, we have to, from the beginning or from the origin, we have to go down. To Atlanta, we do use a negative order pair for it. All right, and then A asks, what is the horizontal distance between the two cities? And to show it on the map. So showing it on the map is going to help you answer some other questions about it. So to get from Chicago to Atlanta, we're going to go right 3 units. But what is that in miles? Right. So 3 units, if 1 unit is 75 miles, we just multiply those together. All right, and then we want the vertical distance. So it looks like we're going to go down 7 units. So what is that going to be in miles?
500
Thank you. All right, and then obviously you guys know that airplanes don't fly that way. Hold on. But airplanes don't fly like that. They fly a direct route. That's why it's so nice to fly. So we want this distance. Now on streets, you kind of have to know the horizontal and vertical, but in the air, we want the straight distance to it. So what theorem in geometry would you use to find that? Pythagorean theorem. And so this leg we said was 225. This one was 525. And what we're looking for here is the hypotenuse. So it's a squared plus b squared is c squared. Or 225 squared plus 525 squared is c squared. All right, did anybody get an answer for this on your own? Good. All right, so I'll go through the steps. When you add those two together, you get 326,250. And then to get C, you're going to do the square root of that. All right, and then for number 3, we're going to plot a point on the map that represents the halfway point between Chicago and Atlanta. What are the coordinates of this point? All right, so it looks like halfway is about right here. If you were going to guess at those coordinates, what would you guess? I'll move in.
-12.5, -0.5. Hold on, I looked at the wrong one, sorry.
That's okay.
6.5.
Yeah.
-0.5.
Right. Right. If we didn't have a map, we didn't have it laid out, but we knew the ordered pairs, could we find a halfway? How do you find halfway between two numbers? Yeah, add them together and divide by 2. You find the average. So halfway between two numbers is always just going to be their average. So all you have to do is average. Whoa. I don't know. I just clicked a bunch of stuff. No. All right. You're just going to average 5 and 8. So that's where the 6.5 came from. So you're going to average 3 and -4. So that's actually the midpoint formula. Right, and then number 4 says that the Denver airport is halfway between LA and a new airport that will be built. What are the coordinates of this new airport? Did anyone do this? 1 4. Yeah. So I think what you probably did is to get from LA to Denver, you go up 3 units over a bunch. 9. And so the new airport, same thing, you would go up 3 over, I went up more than 3, I think. Yeah, over 9. You land at 1-4 in Iowa. Nice job. All right, so on the back, we're going to fill in the notes that we're going to need for the lesson. So we're going to finish learning this today, and then we'll practice it on Monday, which isn't ideal to have a big break, but I think you'll be fine. And I'll help you if you need help on Monday. All right, so this lesson is on the Cartesian plane, and the Cartesian plane is probably the only coordinate plane you've seen. So back there in the back is an example of a Cartesian plane. It's based on rectangles. If I flipped that over, there's a whole nother coordinate plane that is based on circles. It's polar coordinate plane, but the Cartesian coordinate plane is the one we're talking about today. And typically, your horizontal axis is labeled X and your vertical axis is labeled Y. All right, and then the coordinates go around. You guys tell me, there's 4 quadrants. How are they labeled? Do you remember? Yeah, they're labeled like a C. And each point in the coordinate system has an x coordinate and a y coordinate. In quadrant 1, is the x coordinate positive or negative? Good. What about the y? Also positive. What about quadrant 2? What about the x coordinate? Negative. And the y? Good. All right, you guys finish quadrant 3 and 4 with positive or negative for the x and y coordinates, please. And then I'm going to show you the distance formula, but it helps if you just realize it's just like a fancy Pythagorean theorem. So the distance is the hypotenuse of a right triangle. And I would be willing to bet your geometry teacher showed you something very similar to this back in the day. Okay, so the Pythagorean theorem is a squared plus b squared equals c squared, probably the most remembered theorem in the world. All right, and your legs are a and b, so here's a. So let's say we needed this distance here, and we couldn't count units. If I wanted to find the distance between 5 and 8, what would you do with 5 and 8? That's how you find the average or the midpoint. If you just wanted to find how much space is between 5 and 8, what would you do? You just subtract, yeah. And so that is just subtracting your x coordinates. Make sure in the order, well, it doesn't matter. Those should be positive distance. All right, and then finding b, we're going to subtract the y coordinates. Okay. So what we can do now is take what a is, and what V is and what C is and put it into the Pythagorean theorem, and it's going to give us the distance formula. So A is x2 minus x1. It needs to be squared. B is y2 minus y1. It needs to be squared. And the hypotenuse is C, which in this case we're calling D. And it needs to be squared. But I don't want D squared. I just want D. What would you do to get rid of that square? Yeah. So there's our distance formula. D is the square root of all that stuff. Now sometimes that subtraction has already been done and you just straight do the Pythagorean theorem, and then sometimes you actually have to do the whole formula. All right, and then we have the midpoint formula. So the midpoint formula, I'm trying to word this better. We're just going to say finds averages. All right, and then the midpoint is going to be directly in the middle, exactly what it sounds like it is. All right, so anytime we're finding the average, we're just adding the two things together and dividing by 2. So we're averaging the x's and we're averaging the y's. It does not matter what order you add the x's and y's. I keep writing a 2 and I'm trying to write a 1, but it honestly doesn't matter. You can add in any order, it doesn't change the value. Ooh, I was looking at the wrong time. I think we're okay though. We may have to finish this on Monday. We'll see. Alright, so Kenya and Pete met up at Starbucks and drove home separately. Kenya drove 3 miles west and Pete drove 8 miles north. How far apart did Kenya and Pete live? Alright, so here is Starbucks. Kenya drove west 3 miles. Pete drove north 8. Alright, my north isn't perfect, but that's okay. And that should make a right triangle. And we want to know this distance. Can y'all do it on your own? Try to do it on your own. It's the same thing that you did to find the distance between Atlanta and Chicago. So you just square 3 and 8, take the square root, add them together, take the square root. All right, any questions? All right, for number 2, you're going to need to put your phone away, please. Thank you. For number 2, C is the midpoint of this line segment from A to B. We want to find the value of M plus K. So let's start with K. If C is the midpoint between A and B, what can we do to find K? So small. How would we find the midpoint between -3 and 4? Just average them. Add them together and divide by 2, and that should give us k. So it looks like k is going to be 1/2. Alright, finding m is a little more challenging. We're still going to do the same thing. If I know that c is the midpoint, I can average m and -1, so add them together and divide by 2. And then that should give us the y value of the midpoint. Okay, but this leaves us with a little equation to solve, like a two-step equation. So I've never solved equations with you guys before. I don't know how good you are at this, but if you are solving for m and there's something in the denominator, how can you get rid of that something in the denominator? Yeah, you just multiply by it. So anytime you're solving an equation and there's something in the denominator that you don't want, just multiply by it and it will be gone. All right, so what should m be? 5. And so they're asking us to find m plus k. Is 5 plus 1/2, so you could call that 5.5. You could call it 5.5, whatever, it doesn't matter. In this class, I'm not super picky about if you do fractions or decimals. I'm fine with either one. All right, we're good. This last one, I kind of like this question. And I like all of these questions are kind of nice because this is a kind of a geometry concept that they love to put on the ACT, and this is how they ask it. It's usually not straightforward, like what is the midpoint between blah, blah, blah. It's usually something like this. And so I think that these problems are really helpful to help you when you guys take the ACT again. All right, so for number 3, find 3 different locations for a new point C such that AB, so this distance, will be the same as AC. So this is kind of like the new airport situation. So what I did is to get from A to B, you go down 2, right 3. So C can be any combination where you move 2 a certain amount and you move 3 a certain amount. You move 2 a certain distance and you move 3 a certain distance. So what is one point? It could be. You say what? 5, 5? Yeah, 5, 5. You go up 2, right 3. Good. Anybody else? 0, 6. Yes. For 0, 6, you go up 3, right 2. That's perfect. It's still going to be the same distance. All right. One more? Anybody? Say it again. -1, 5. Yep, so that's up 2, right 3. Good job. All right, there's many more, but those are perfect. All right, so we'll stop there for the day, and then Monday we'll practice.